Hey everybody, and welcome to another video in the Microsoft Certification 70761 series. My name is Elric, and in this video we're going to be talking about pivot and unpivot because they're a little odd one out for transformation queries. And then we'll be talking about temp tables, global temp tables, table variables, and finally CTEs. And with those CTEs, I got a crazy demo for you, both descendant, ascendant, recursion, and what to do in a cyclical dependency recursion. Like if my parent has a relationship with the child, which has a relationship with the grandchild, which has a relationship back to the parent. So got a neat little demo, which hopefully will clear up recursion for a lot of folk. And yeah, before we get started, in the description, you will find a link for 005 tutorial scripts. You can go ahead and download that, experiment with it, do whatever you want so you can get prepared. You also find, given spoiler alert, you will find create scripts, which I greatly modified with different procedures to help showcase how session context works with tables. And something I want you to note is that normally I have used the pattern where I drop and then I create, I drop and then I create, but I had to do something differently because when you try to drop a table type, which is going to be used in this explanation, you cannot modify nor drop the table type if it is ever used in a procedure. So that is something to be aware of and be careful about, is that if you ever decide to use table types, and if those table types ever change, you need to create a new table type, replace them in all your procedures, and then drop the original table type. It's a very tedious process. I don't use these user-defined table types because of that, and because there are other ways to pass data back and forth that we can cover in the JSON bit of this series. So this is the new scripts, and we can run it multiple times just so everything's up to date. It does contain all the original information. I just keep adding on to things, so if you get the latest script, you can go back in time and still be good. So both of those links will be in the description. Also in the description will be minute markers, so you can skip ahead or jump around to a specific subject if you just want a refresher on that subject. I do recommend that you watch this video in its entirety, just in case there's something said that you may or may not know. But other than that, feel free to do just that. That's why I take the time to put those markers in here. Lastly, if you leave a comment, I missed something or said something wrong, I will place your comment in the description under a section called additional comments. So feel free to check there to see if there's anything in this video or not in this video that you should be aware of. So before we get started, like, comment, subscribe, and let's get started. So the first thing I want to cover is pivot and unpivot. So pivot and unpivot have very similar formats where you select from something, and this something is usually a subquery but can be a table. And the reason why I'm using a subquery, I'll uncomment this information, it'll make more sense because that pivot may not produce the correct results. So a lot of people get in the habit of using it in this subquery context. So the structure is basically the data I'm getting, transform, value, column. And same with unpivot, it's value, column. So above the subquery, once we transform it, we can immediately start calling that data. We don't have to abstract this or push this, nest this, back one out, whatever. So we don't have to do select from, parentheses, select from, parentheses, purchaser quantity, etc. It's very inline, and that's why I formatted it like this. Because you get the data, here's your table, and you pivot. So this could just be from table pivot. That is a possible thing. So this is the data that we will be pivoting. And what pivot essentially is we're turning vertical storage or vertical data into horizontal data. So we want to create columns from values. This internal query will get us the stuff that we need, and then we transform it using an aggregate and saying what we are looking for the new columns. So in this case, we are saying we want to sum all these quantities, so we expect to see 157 and 137 somewhere. And we are looking in this purchaser column for these fields. Now these fields have to be defined. They cannot be dynamic unless you are creating dynamic SQL. You are constructing this, then it's, do what you need to do. Also, I'm going to add another name in here, just because. That's what happens when you row copy. And I will call it up here. This will help me show how this handles pivot handles nulls, and that you don't need to have the values in here in order to pivot them. If you expect them to eventually be here, you can pivot them anyways. So let's go ahead and just run this pivot. And what you see is what I described. We get the sum, 157, 137, and now we have columns. So we can go as far as we want, like week numbers. But similar to group by from our last video, if we call more than what we pivot, we will get a different result. And so if I run this again, we get expansion. That expansion happens because it's this weird cube-like item, this Rubik's Cube almost, where if we're calling more than what we pivot, that's what it's slicing the data by. And it's doing that because that additional column is a different slice of data. So just know that when you call additional things, like especially a primary key. So if you call a primary key in here, it really doesn't do much. Let's do that just for an example. We get this weird staggered stuff because it's trying, there would be a quantity right here that would equal this or this. So just something to keep in mind. Now unpivot is the opposite. Unpivot is we want to take this data, these columns, and turn them into values, like turning it to a side, Rubik's Cube, rotating counterclockwise. So we want to take this data and we want to create a column that holds these values. Product, quantity, date sold, date time sold, date shipped, date time shipped. So that is what we're looking to do. I'm going to run this whole query first just to show you that it will not work. So we're getting an error. Now this is because we have strings and we have a different data type. So we must make sure that all of these columns are the same data type. And because strings are almost that universal, you can put anything into a string, but you can't put much into other data types. Yes, you can make a date numeric, but strings like the universal container. And just real quick, if you've never seen what I just did, you hold Alt and you do some magic, copy paste. It's called column select. If you're ever interested, look it up. It's really awesome. But I digress. So I'm going to convert all of these to strings, and then like I said with the pivot unpivot being the same, it's value and then column. So in this case, we don't need the aggregate. We're saying this is what I want the column to be called that is going to store all these values that I had. And this is what I want the column to be called that's going to store the name of the column that these values came from. So when I run this, it should make a lot more sense. And same kind of setup. From a table or subquery, unpivot that information. So now I get a dimension where, this product is burgers, the quantity, dates sold, etc., etc. So that's the unpivot side to it. Now, since I have two values, I'm going to take these values out in a specific way because I want to show you date sold how unpivot handles nulls. So I'm going to say if date sold equals this value, then I want you to return a null, else I want you to return date sold. So I am specifically replacing this one value with null. And currently I have 72 records being returned. So when I run this again, I lose those 2 records. Unlike pivot, which filled in the null when we didn't have Tina, unpivot removes null records, so you get a very precise set of data. Just something to be aware of. Also, unlike pivot and unpivot, unlike pivot, we do not need to get all this information back. We can call more than what we, unpivot on, because it's just expanding and it's not trying to limit. It's not trying to aggregate, so we don't get that expansion. Purchasers, the great example is that there are only so many rows here, but we're expanding into 70 rows. So if you call more than what you unpivot by, it's completely fine. And that is it for pivot and unpivot. And now we're going to talk a lot about tables. So the first table I'm going to talk about is the temp table, just the single hash temp table, or the single, what's this called? Octothorpe. Yeah, lesson of the day, Octothorpe, because there are 8 thorpes on it. Single hash table. So I'm going to declare and insert values and select from this temp table, and I get my data back. Now, explaining context is how SQL handles context is a little difficult, because when we call procedures, it changes. So currently, I have access to this table in this code. However, spoiler alert, I do not have access to this table in other sessions. Each of these queries is each of these windows is a new session. Think about it as 2 individuals connecting to that item. To SQL. Once that connection is closed, you lose that information, and that's what I'm demoing by opening up a new window, trying to get information, and it's not there. But still, we have access to it in this same context, even though we're not doing anything. And we can drop it. This table, or this procedure, all it does is create a table and insert values. And this procedure will try to select from that table. So what I'm trying to show you is, creating this table, selecting from that table, and we'll try to do it again, selecting from it down here. So I created this table and filled it in this procedure, but I don't have access to it in another procedure, and I don't have access to it in the same procedure that I had called. Oh, because I am calling it by the wrong name. Yep. Same thing. Damn it. There we go. temp table, temp table. I'm calling this temp table, right? Yep, okay. Sorry, just wanted to make sure. I saw that the names mismatched. Tried to make these tables unique. So even though I created a table over here and I tried to use it in a different procedure, I don't get that information back. I'll actually have to send that information back, and that's why we have that UDT created. Now for the double octthorpe table, this is called a global temp table. So just like with the other temp table, I'm going to create, insert, and select. So I get these values back. Now this is a global temp table, so I can call it as many times as I want. I could create a new query window and call it from here. So this isn't a session specific object. This is almost like a normal physical object on the temp directory. So it gives you more control rather than finer grain, more access to it, more context to it, unlike the normal temp table. And same thing, same kind of demo where I can create this global temp table in this procedure. I will select from it in between, because in here, actually I'm gonna copy this so I make sure I'm right. In here I'm gonna select from it again and then just drop it. So you can see it traverse through stored procedures, and I'll just do star. So I created the table, I was able to immediately call it, and then I was able to call it from a different procedure again. So this temp table, and this procedure also drops it, so I don't have access to it anymore. But this global temp table allows you to use it all over the system. So it's you kind of have to be very careful about putting personal information, user specific information in these tables, unless that is that purpose that you are looking for. And if we constrict the control even more, we have a table variable. So I'm just declaring and filling this table variable and immediately selecting it like previous examples. But when I go try to select it again, it's not there anymore. So this lifespan is even smaller than the previous tables. And attempting to send this table to a stored procedure, I get a type mismatch. Even though the types are the same as this table that I declared. Let's see. Oh, it's in create scripts. The types are the same. It will not let me pass that data forward. I get an error. The only way to send a table to a procedure is by creating that type. And let me drop this window down. The declaration of these tables are different. I had to actually declare a table and give it its structure, but because we created a type out of it, I just needed to say, hey, like object-oriented items. Instantiate this new object with this item, with this schema, this model, this definition, whatever you want to call it. So when I declare it, it's immediately saying, all right, this is a table, and here are your columns, and here's what's going on. In this specific, because we are declaring it as a predefined table type, we can send it to a stored procedure, and this stored procedure just selects from this table, and we can get it back here. We can use it again outside of that stored procedure. But this is that stored procedure. What I wanted to show is that if we do not say read only, it will not allow us to compile that procedure. Sending a table forward has to be read only. Even if we try to add some sort of try catch and insert the value into this table, the compiler catches that and tells us you cannot do that because of, it's read only. So it's very interesting. I mean, you do get some control of passing tables back and forth, but you don't get much control over that object. So there are better ways to do that through something like JSON. I'll cover JSON in a later video. And those are our main table types, our main objects that we can pass around. And now we go even smaller with CTEs. So CTEs are kind of like tables. I can declare this derivative of a table where I just want a distinct purchaser. I just want this data as a quote unquote new table. So I can select that data, but it is gone. I have no access to it. And it has such a short lifespan that I can only select from it, and I'm required to select or I'm required to perform an action after I declare this CTE. So even when trying to call it again in the same execution, I've already done my statement, therefore it's no longer accessible. Now declaring a CTE, because it's a first item in the batch, we don't need that semicolon. However, it is a very batch specific thing where, because I have some other code written before this, I need to terminate what is happening in order to declare this CTE, which almost limits the number of areas that you can use it because of this termination. There are other areas like defining cursors and inside of functions where you do not need to use this as long as it's that first item. So you don't have many options in other places rather than stored procedures and ad hoc queries where you can use this because you have to terminate in order to begin constructing this CTE. Also with CTEs, we can chain them. And in this particular example, I just want to show you that I've declared primary CTE using the with, which is just distinct purchaser. And just like everything else in SQL, updating multiple columns, selecting multiple columns, it's just comma delimited. So comma, here's the next object I'm declaring. Comma, here's the next object I'm declaring, and just to show that I am using these previous CTEs inside of a CTE. I do get all that data back from the Cartesian. This is showing that I'm just calling one of the 3 defined CTEs, so you don't need to use them all in your code. And 2, using union all to get all of that information back. I'm kind of using the union all to extend out the life of the CTEs because it's considering it one giant select query. So I got all of my CTE data back. I think that's about as far as we can go in the normal uses of CTEs. So let's jump into this demo. And recursion is a crazy thing. It's a really difficult thing to explain. So I'm going to try my best to explain what is going on. So I'm going to start with just the data I'm using because I abbreviate it in the comments above so it can fit on the same screen. I'm using just simple great-grandparent is the parent of grandparent, grandparent to parent, parent, child, child, grandchild, grandchild, great-grandchild. Just a simple kind of hierarchy of parent-child relationships. For the CTE, for a recursive CTE, there are 2 parts. There is the initial pull of the data, and then unioning, union all more specifically, the same initial pull of the data followed by an inner join of the CTE you're currently in. There's a very odd concept where we're basically, all the data that's being pushed out here is being pushed into the union all and joined, and that's that recursion. So we're going in that circle. So let's, I'm just gonna run this and then we'll explain what's going on. And I'm gonna go to grandparent because that makes the most sense when we first do it. So notice that I have grandparent here multiple times, and here I have 0, 1, 2, 3, 3, 4, 4. And we're gonna look at the original data set. So it's first I have grandparent, great grandparent to grandparent, and that 0 basically represents that that direct relationship. In fact, we could make that whatever number we want because I'm statically declaring it. You know, count starting from 0. So this is the immediate relationship of what the relationship between the two. Now looking at this data, great grandparent to grandparent, grandparent to parent. Parent is one jump away from great grandparent, and that's where we get that 1. And then it just keeps going from there. Grandparent to child is 2 because we go from great grandparent, so 0, 1, 2, then to grandchild. Both of these are 3 since it forks out, and both of these are 4 since it follows that different tree. And that's what we get down here. So I'm going to try to explain what is happening behind the scenes. I don't know the order in which I should explain this, so I'm going to try it in this way. This is the result of the recursion. And this is a parent, and this is the descendants, because we're going to start with descendants since it's way easier to explain. So this is redundant data followed by different steps or distance from this original data point. Even going down to parent, you can see parent child, parent grandchild, grandchild to great grandchild, but there's no parent to grandparent or great grandparent because the descendant is looking at the current scope down only. And to do that, we're calling the parent-child relationship from our object, and we're unioning that same parent-child relationship from that same object. Except, and this is really weird, this is really, you know, I mean, it makes sense once you understand. We're interjoining the whole query that we're doing, the CTE itself, onto the CTE's child, meaning the data that's spitting out, the child, onto the original data set's parent, which would be here. So that's how we get, you know, the CTE children that's being spit out to the original parent. So if we have this grandparent, we're going to join that table again, and we're only going to join it on grandparent. And then because grandparent is there and we have parent, we're only going to join it on parent. Now what escapes a lot of people is the columns that we return. So the easiest way to remember that is if we are interjoining on the recursion child and the original parent, we need to get the opposite. So the opposite of the recursion child is the recursion parent, and the opposite of the original parent is the original child. So that's how we get the data that comes back here, and we avoid all of those recursive errors. And I'll show you a recursive error later on because we're going to talk about cyclical dependencies. And here's some comments that I tried to better explain this using this data set, a limited abbreviated version of the data set below. When we do that first union, we're pushing, so this would be the original table. and then this is the top of the CTE for 0 for nest. And when we're doing that first union with that inner join, we're taking the original table and we're trying to join it on to this CTE. So what's happening is that, as you can see, it almost lines up. I basically took this chunk and placed it up here and took the bottom and put it on bottom because, like I said, we're inner joining on the recursion child and the original parent. We're joining on the child and that original parent. But what we're selecting back is this great grandparent, or this parent, and that's how we get that specific list. So the first union, when we interjoin child to parent, one of our records disappears, and our select statement on bottom is just nest plus 1 to let us know that iteration. So we take this information, and now it's just, this bottom information plus 1. And that's how we move this data. But the recursion will keep going until it gets no more data, until it runs out of rows to process. So the second recursion, you get that recursion child or recursive child to the original parent, but you have less and less data to work with. So I have only P and C here. P and C, because there's no grandchild as a parent. And then again, with that third recursion going all the way around, I even have more or less records to join with. So focusing on this, each of these, this is almost the entire data set that you're going to get back. If you think about it, from this query, I'm saying give me the recursive parent back and the original child. So if I were to copy all of this data, say only show recursive parent and original child, I would, so this is the recursive parent, this is the original child, this is not the recursive parent, this is the original child, this is not the recursive parent, this is the original child, this is not the recursive parent, this is the original child. So what I have is GGP. Is this still up? Yep. Sweet. So I have great grandparent and grandparent at 0. Oh. Because I said show the recursive parent, I have GGP P1, so great grandparent parent 1, great grandparent child 2, great grandparent child 2, and lastly grandchild 3, which this data goes farther. So that's how that data works, and it even parent to grandchild, or parent to child 0, parent child 0, parent to grandchild 1, and that's it for this particular data set. It's a very different thing to just realize that you want the same parent in that recursion, because you're not really looking at the data in how you normally look at data, which is, left join ad infinitum to get multiple columns. It's doing that, but it's still trying to keep track of where it came from. So ascendant, ancestor, that's actually called it as ancestor instead of ascendant, is technically is like the opposite, the exact opposite of descendant. Here I'm selecting parent child, Here, I'm selecting child parent. Here, I want recursive parent original child. Here, I want recursive child original parent. But using the same thing, the same rule, because I have recursive child and because I have original parent, my join is the opposite. The opposite of recursive child is recursive parent. The opposite of original parent is original child. So I can, and I will run both of these so you could see what is happening. Flipping the logic around, in the top one, I get child to grandchild, child to great-grandchild. It has nothing to do with parent, grandparent, and great-grandparent. However, in the ascendant, child doesn't have anything below it. So directly above it is parent. Directly above, or one step above that, is grandparent and great-grandparent. So you can use recursion to go either way. And I highly recommend you experiment with or rewatch this 100 times. Ask a ton of questions. This is a very, very important thing to know and understand. Maybe try to write them with your own data. I mean, that's something that might help, is change this data with something that makes sense to you. Whether, it's genres of music and the different parent-child classifications, the etymology of genres or anything that has a hierarchy. I recommend replacing this data and running it, because you need to know this. And then just practice writing them on your own using this as a reference of what am I supposed to be doing. Some people call this level, nest, leaf, step. It's whatever you want. At this point, it's just a marker of some point. So, almost lost connection. Now I'm just going to throw some curveballs, because this is a real world example of parent-child, something that us as data people can relate to, but it's a cyclical relationship. So I build insane master data management systems that do anything anyone needs, basically. Very limited development required. I speed through these in a few weeks. But because of the design patterns, I have a people table that has a type ID or a type table that has a family to class. A class has no parent. Now, I could also, go people to name to type, family, class, realm. You'd have to really understand my model to understand that V shape. So I have basically just taken a small section of that and saying, in the context of a person, its foreign key, its child could be type. In the context of type, it could be child, could be family. In the context of family, its child could be class, because it's just a foreign key. It doesn't have a direction. And then going the other way, if I'm a class, my child could be family. If I'm a family, my child could be type. If I'm a type, my child could be person. So we have this cyclical dependency where if I ever join these two, they're going to get stuck and just spin. And that is what, because I have this solution here. I want to show you it spinning around. Doing the same thing, recursive child to original parent, and get the opposite. I mean, this is almost identical code from above. Oh, I should remove that word. it tried to spin around for 100 times, and it didn't give me any data back because it probably got stuck on joining person to person and just spun around. So this is a really common error with recursive CTEs, not understanding that pattern and how that data works. But in the event that you have parent-child with no null parent, because that's another thing that you're recommended to do, we'll have a null parent. Well, a null parent really doesn't take away the fact that you have cyclical dependencies. So how you get around that is building a tree, and that is a even more insane thing to explain, but I will run it and then I will explain it with the data in front of me. So the tree, like we have the distance as a nest, the tree starts off with the parent, comma, the child. Because recursion, we are taking the child and joining, the parent to it to get another child. That is how that recursion is happening. So by creating a tree where I have the parent and then the child, and then adding onto that tree the additional child, it will help me create the lineage, essentially, of everything that's happening in this recursion. And how you actually prevent the infinite loop is you're saying, hey, that child that I'm going to join, and it's very important because like I have person, TBL person exists inside of TBL person type, but is not the same object. It's really important to char index that comma at the end of it to say, hey, I'm looking for this complete object and I know it's going to be looking like this. So this is saying before I add my child onto it, make sure my child's not in the tree already. So that's how we can break that recursion and get data back for both directions. We have from person to type is a direct relationship, person type, person to family, person type, person family, person to class, person type, person family, person class. Class, well, class goes to family, class goes to family and type, class goes all the way down to person. Family, it's pretty interesting. We go up, family to class, and then that's it. We have a duplicate 00 for family. And then family down goes family to type, family to person. Same with person type. We go down, we only have person, and then we go up, we have person to family and person to class. So this, hopefully this cyclical dependency thing kind of sheds more light on how that recursion works, where it is really just tacking on that extra step, looking for that additional piece of information until it can't. And no matter what format your data is in, as long as you can get that parent-child relationship, cyclical dependency or not, you can use a recursive CTE to get your answers. You just have to understand if your hierarchy is in the middle, it will give you both directions. And if we made this longer, we would have more duplicated results for the zeros and the ones, because you would almost create a V. So hopefully this was a very informative video. I know recursion gets a little mentally puzzling or challenging. That sounds kind of bad, mentally challenging. But it is something that needs to be discussed and something that you should prepare to be asked about. Because it's not just querying with T-SQL, it's querying with T-SQL where a small section of it is advanced, and we do not know what is coming from that advanced pool. So thank you very much for tuning in, and thank you all for your support thus far. I'm Elric, and like, comment, subscribe. If you have any questions or want more information on this recursive CTE, feel free to ask, because this is a pretty complicated subject. Thank you again, and you guys have a good one.